And we are starting our lecture program for our DeepHack.Turing school. And it's my great pleasure to introduce Danica Damljanovic, who had PhD in natural language processing, and she's also CEO and co-founder of the Sentient Machines, a startup in the area of natural language processing. So welcome, Danica.
Thank you. Okay, so everyone can hear me well, I'm assuming. So thanks for the introduction. So I come from Sentient Machines, as Mikhail mentioned. So I'm a co-founder and CEO, and what we do is we analyze phone call conversations in order to detect frustration in particular and why are people frustrated. Prior to that, I worked in different startups, either building dialogue systems or analyzing dialogues. So in this talk, I will share some of the experience I had, and I will also talk about some academia concepts that are actually very, very important and core to all the research and work I've done to date. So first, as I said, I'll talk about dialogue systems and some basic concepts. So I'm not going to list all of them, but here are like turn-taking, emotional expression, grounding, and so on. So those concepts that are actually necessary to know when you are building such systems. And I will also talk a little bit about differences between chatbots and voice bots, which is, I think, when you are building them, you only notice the difference. When you're using them, usually, actually, there is no difference. So finally, I'll talk about challenges and applications of understanding spoken dialogues. So the second part is really about voice. I should have, I'm going to be clicking quite a lot now. So when we talk about dialogue systems, so all the concepts we could apply to actually building them, but there are some applications in particular in industry that require you to basically use the same concepts to analyze these dialogues. So for example, I don't know, meeting summaries or recording face-to-face conversations, you need to apply basically similar techniques. So first about building dialogue systems. So I'm sure that all of you here are familiar with this definition, which is basically that a dialogue system is a computer system that is capable of conversing with a human with a coherent structure. Now, I underlined this, and this is a very, very important. This is a very important feature of dialogue systems. Have I done anything? No, good, okay. So when we talk, so human-to-human dialogues, usually coherence is not something that we actually even think about. When building these systems, for example, if I show you these two dialogues, they both kind of start the same, but if you spend 2 seconds looking at them, you could probably tell which one isn't quite making any sense. And this is where we are talking about coherence. So basically, the first one is building up. So if the question is, have you seen Dancing with Wolves? The response is basically kind of related to that particular question, and then the conversation is kind of building up and as the dialogue develops. In the other case, we've got Dancing with Wolves question followed up Chinese food response, which doesn't quite make any sense. And it doesn't usually, as I say, happen when we talk with each other, but when we're building systems, it's something that's very important that we need to think about. So in this talk, I'll talk about some techniques on how to basically build coherent systems. So why are dialogue systems important? So we have chatbots on one side where the communication is using text. And on the other side, we have voice bots where communication is using language. There's quite a lot of popularity or demand in industry at the moment, and in particular in the last few years where people are very excited about chatbots. And the reason is that natural language is very intuitive, so we all use it. We speak this natural language, and being able to actually communicate with the computer is also quite exciting. So some statistics shows that by 2020, 80% businesses actually want to have chatbots. So it's basically now up to us, can we build chatbots that are actually good enough to kind of satisfy this demand. Speaking of voice bots, and in Sentient Machines, we actually work with customer service a lot. So surprisingly, almost 70% of customer contact is using voice. So people love talking. They love picking up the phone. And this is why voice bots probably will also become as popular. Another example, statistic from WhatsApp, that there is 100 million voice calls per day. Now, this is quite a lot of information. Now, these systems, both voice bots and chatbots, could be improved by using graphic interfaces, haptics, gestures, so whatever it takes to actually improve the user experience. So talking about basic concepts now of dialogue systems. So the first one is a turn-taking one, and this one is actually relatively obvious. When we speak, when I, for example, speak, now it's pretty much a monologue unless someone asks a question. In dialogues, it's natural that people are taking turns and they're talking and so on. And again, in chatbots, what usually happens is that there is quite a lot of that's being said in one particular turn. Like in this case, there are 3, I think, sentences that are kind of given in response by a user. And then the bot on the other hand, can everyone read actually this, or do I have to, can you read? Can you see? Yes? Okay. Otherwise, I can kind of read some of it. I'm assuming you can all see it. So you can see quite a lot of text here. So basically, and I'm sure you all had an experience where you're talking to a chatbot, and even if it's just like a chat with a human on the other side, when it says, is it my computer or is it? Well, basically it's saying the user is typing on the other side, and basically what you're doing is you're kind of waiting for them to finish, and then you continue. So in that sense, there is not much interruption. The conversation kind of flows, and one speaker goes, the other one responds to everything that's being said, and so on. Another important aspect is emotion. So if you see here, the user is saying on top, I called you twice already about this. It's really, really annoying. So it's obviously he's not happy. And then down here, he's really happy. So if you would be seeing this, you would probably imagine someone saying, really? You don't know? Like someone really, really angry. But what happens is people use a lot of punctuation, like exclamation marks, question marks, different emoticons, and so on, to actually say, I'm not happy. Can you do something about this? So this is chatbots. When you talk about voice bots, the situation is slightly different because what happens is that people interrupt each other quite a lot. But before even that, when we are building voice bots, what we have to do is we have to transcribe what's being said into text. And even though there have been some amazing breakthroughs, in particular last, I think, 6 months have been amazing, we still have to solve sometimes the problems of what's called the word error rate, where the user here is actually saying that this is Duff Smith, but actually is getting something like Dog Smith in return. So it's quite a big error because this isn't a name. It's not quite what he's saying. So, but I think, as I said, there has been some breakthroughs there, and I think we are very close to actually solving this problem. The second feature of spoken dialogues and voice bots is that there's a lot of what's called back channeling. So if I'm talking to you, you might be saying, yeah, continue, which basically means carry on, I'm listening. And this is especially if you're talking on the phone, because otherwise you think, well, are you gone? Are you gone or are you there if no one is saying anything? So, and this, when we are building systems, we kind of have to take this into account. So we need to actually ignore this, and not be bothered to even analyze. This basically means I am here, I'm listening. It doesn't mean anything else. In some other cases, a user might say something that actually requires attention. So in this particular case, he's saying a new part, quite angry, whereas the bot is basically continuing as if nothing has happened. Now, this is arguable if he should do that or he should actually stop and show some empathy towards like this new part and why it was an issue and so on. So the challenge again here is to be able to distinguish between proper back-channeling and utterance that actually requires attention. The next concept I've already mentioned a little bit, which is around emotion expression. So when we are talking, again, and when we are typing, we use our language differently. The cognitive process is different. And with voice, we also can express certain features, like if we are unhappy, we could just shout. With chatbots, as I mentioned, it's usually punctuation, it's strong vocabulary, emoticons as well. With voice, the tricky bit is different cultures use voice differently. So what would be very polite maybe in Russia might be considered rude in, I don't know, England or India, or I don't know, different culture. Like in India, they would say yes to pretty much anything, which doesn't actually mean yes. It's literally we are talking and so on, which is what I mentioned earlier. In some other cultures, it's kind of, so you have to think about this when building systems, and in particular when you're collecting data, you need to understand where are data coming from and how to use this. So grounding is the next concept, which is very important, which basically means we need to establish a common ground when we talk. So if I say something, you might want to repeat it back to make sure that we actually are on the same page. And this is actually, again, in human dialogues, we do this all the time. So in London, when I call customer service, often I speak to Scottish people because customer services are based in Scotland. It's very hard for me to understand. So what I do is I basically play back. I summarize what I think they said, and then they say yes or no. They start explaining. So we do this. It's very natural. So when we are building systems, we kind of have to do something similar. So if the user is saying, I would like to take the flight on the evening of the 4th of July, to make sure that it's the evening and not anything else, the bot might play back the evening of the 4th of July just to get a confirmation before the booking. In some more complex cases, we need to add some inference. So if the user now wants to be there on the 4th of July, the bot needs to infer that basically means his flight needs to be there before 9 a.m., for example, on the 4th of July, which is where we basically need to think about how do we actually add this knowledge base into the bot when we are building it. So reasoning, another important concept. So this is where sometimes we say things, but we don't actually say everything. There is context, there is some history, and so on, and there is a lot of inference that's happening. And this, again, looks obvious, but when we are building systems, it's actually quite important to consider this. So in this case, the user is hungry and wants to eat, and is inquiring about restaurants. So the bot is saying, what kind of restaurants would you like? And then the user is saying, well, something healthy. Now, healthy for me might be different to healthy for someone else, and so on. So this needs to be defined. This needs to be defined in the knowledge base of the bot. And for example, we could use ontologies and do something like this. So we could say, well, raw food is considered healthy, and Japanese cuisine has raw food. So therefore, we could just infer that Japanese food is healthy and maybe give that as response. So if the bot plays that back, the user might now say, well, I can't have any carbs. So basically, the problem is not solved. He now needs to go and find the information about the menu and see if there are carbs in the menu, and maybe try to find some other option or alternative for basically healthy. So another very, very important part of reasoning is when you're building chatbots or voice bots, you have to think about the situation where you just don't have the answer. Maybe it's not in the knowledge base. Maybe you don't know how to infer it. But you don't want to be saying, I don't know, all the time. So what you can do, and in this particular case, we have a boy asking about how many cells are in my knuckle. And this is actually from the system we built where we were simulating a teacher and teaching kids biology. So the bot is saying back, well, I don't know about the knuckle, but I do know about the wrist, and there's 1 billion in the wrist. So it's kind of giving a response that's not exactly the response, but kind of showing also that there is some knowledge. And to do this, again, it would rely on a structure that is behind the scene. And in this case, we had an ontology, and a wrist and knuckle were both part of a hand, and hand was part of body. So it could infer something like this. Next concept is around personalization. Now, when we talk about personalization, this is, again, if I have a conversation with a computer and you have a conversation with a computer, they don't necessarily need to be the same. And ideally, they wouldn't. So now I don't know if you could exactly read this. I'll try to explain. So basically, what we have here, and this is, again, from the system where we were teaching kids biology. So we have two users. The pink one is Anna, and the blue one is John. And Anna is both of them actually asking about biology. Now, in this example, we are using what we call short-term memory, which is basically the memory within this session of a dialogue. So you probably are familiar with a long-term memory concept. So long-term memory is things that you actually save, for example, into user profile, and then you could use this. So in this particular example, what's happening is the bot is making a decision on what to say next based on how many questions have these two users answered correctly previously. So the system actually works like that. You say, I want to learn biology, and it's firing questions back to you, and then you are responding in using natural language, and then it's kind of monitoring your progress. So Anna has answered 3 questions correctly, whereas John has answered 3 out of 5 incorrectly, and therefore they are treated differently. So what happens, and if you can't read, I'll try to kind of guide. So basically for Anna, the system is moving her to the next level, which is grade 7, whereas John is staying on the grade 6, and he's basically rehearsing some of the questions that he already had. So, so this is basically, one way to personalize systems based on what is actually happening real time. So here in the middle, we see something called Kai platform. So this was initially developed by the SRI, where after they sold Siri, then we were adopting this for the learning scenario. So the structure of the system, and this is not by no means like the only way you could build systems, is where you have natural language understanding at the beginning, so NLU, which is basically interpreting what's being said. Then you have the reasoner as a second component, which is basically taking that interpretation, taking the context, and then generating basically the action points for the NLG, or natural language generation model. And the natural language generation is basically generating those dialogues that you see. So in the next example, this is about long-term memory, so it's a similar scenario, but in this case, what's happening is that we have some information about the users. And in this particular case, we know that John likes ice cream. You can't probably read, but it says ice cream somewhere on top. And Anna likes running. And because of this interest, the assumption is if you connect learning concepts to things that people like their hobbies, then they would probably be incentivized to learn faster. So this is what's happening here. So we have an ontology with hobbies, sport. We know that sport is related to fitness. We know that food is related to nutrition. And because of that, we are able to actually generate something like the topic of fitness will allow you to apply your prior understanding of cells. So it's basically connecting cells, which is what you learned before, and fitness to actually go into the next topic. And the question is, what factors affect fitness up there? For John, it's talking about ice cream because of his interest. And it says, as you enjoy ice cream, would you like to learn how it affects your body? This is covered in the topic of nutrition. And let's talk about that. What is the function of calcium in the body? So obviously, it has found some relationship between ice cream and calcium and food, nutrition, and so on in order to generate this dialogue. So these are just two examples of personalization. There's many, many more. And they are actually quite useful if you want to build systems that are actually quite fun. So the next concept is dialogue acts. So when building dialogue systems, it's important to understand the structure of a dialogue. So am I opening at the beginning, saying hello? Is the conversation progressing, saying thank you at the end, and so on? So this is what kind of goes under the concept of dialogue acts. So just to go back into when this all started, so there were speech acts, I think coined in 1962, which is basically the assumption that whenever you say something in a dialogue, there is a certain action that needs to follow up. And we also call this an intent. So what is the intent of something that I actually say? So this was basically the beginning of dialogue acts. Dialogue acts are building up on speech acts. So we say that there are annotations basically over utterances, where we basically defined what is the function of a certain utterance within this dialogue. So to give you some examples, and this is from a famous speechbot corpus, which was basically annotated. So you could see, I mentioned, for example, conventional opening. So hi, how are you? Or closing, goodbye, or it's been nice talking to you. Then a WH question, or we call them sometimes factual questions, where basically you're saying, I don't know, how old are you? Or what's your address? Or something like this that requires a fact as a response. Statement non-opinion is any statement where you're not actually expressing your own opinion, as opposed to statement opinion where you're saying, I think this is what you should do, which is basically you're expressing your own opinion. Some other ones that are important are, for example, repair is a very, very interesting one because, and this used to be my favorite one when we were analyzing dialogues, where people are literally saying yes, yes, yes all the time. And then suddenly, oh, sorry, I meant no. And you've got like this yes, 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 oh, no. And you need to basically capture every single word in order to understand that actually they meant no. So you can't apply any kind of keyword-based or rule-based approach. It's actually quite tricky. Summarize or reformulate is related to the concept of grounding I mentioned earlier. So it's around. So the example is you mean she is better now. So basically, I'm summarizing. I'm using different words to say what someone has actually just told me, to summarize and make sure. Okay, I understood. This is what it means. Signal non-understanding is common. I beg your pardon, or excuse me. Sorry, I couldn't hear you, and so on. So this is also very, very important. Third-party talk. So this is where I talk to you, and there's someone over there, and I need to tell them something. Hey, could you please stop laughing? And then I continue. So this is also important to understand because when we are looking into dialogues, we can't be distracted by kind of third-party talk and similar things. Rhetorical question are questions that don't actually require any response. They could appear anytime, anywhere. Like in this case, who would steal a newspaper? I mean, it's just like, who would? Another important concept around dialogue acts is that the sequence kind of follows. Certain dialogue act types follow certain other dialogue act types. So you could see here, for example, that we have some questions, we have some responses. So naturally, yes response would come after yes, no question. Whereas if I'm asking a clarification question, this could come up anytime. So it could come up anytime. And when you are training systems, you have to actually account for this. So an example of how this looks in practice. So we have a question, can you provide your name, please? Now, if you look at this question, I mean, I could say yes. Yes, I can. Yes, I can provide a name. But probably I wouldn't, because I know I'm inferring already that they want a name. So therefore, even though this question has a structure, grammatical structure of a yes-no question, it is actually a factual question because we are expecting a fact as a response to this question. So another important concept, even though it looks useless, but it's actually very important to be able to detect something that's uninterpretable, so something that you can't actually use, because otherwise you could actually try to interpret it and say, well, is his name, and it is, it's not. So because it was uninterpretable, the bot goes back saying, apologizing first, and then signaling not understanding. And in this case, you can see that he's saying the line is breaking. So that's one way to signal, well, I couldn't actually hear anything you said. And then he's rephrasing the question, saying, what was your name again? And then he's able to kind of give back the name. So now that's about what they are and how we use them. But then how do we actually build classification systems for dialogue acts? Traditionally, there have been two main approaches. One is called planned and inference model, which is based on beliefs. And this is basically, if I say something then to someone, that someone is trying to interpret what my belief is. And therefore, we try to basically correlate using this belief, trying to align our beliefs. And this is used to be popular in systems of a very limited domain. So there used to be one called trains and later trips, which was basically about booking trips. So when you are booking trains or flights, there is a very limited kind of set of questions and intents and beliefs that could be exchanged. So therefore, in that particular case, it could actually work very well. For more complex cases, it's actually quite hard to build systems using this approach. And a much more popular is what's called a queue-based model, which is basically now relying on the language that we say. We are trying to detect what kind of what dialogue act type it is. So to give you some examples, so queues could be, and actually queue is a clue, so it's just been a word kind of that left L on the way. So basically, it's different words that could give you a clue that something is of a certain dialogue type. So if something, for example, if a sentence begins with what, then it's very likely that this is a cue towards a factual question than if a sentence starts with is or something like this. So when we build these classification systems, we have to, just like in any other classification problem, we have to think about features. So how do we encode features before we actually decide on the algorithm? Because we could use any algorithm, and in fact, there are quite a lot that have been used for classification, dialogue act classification. And without going into details about all of them, so we have hidden macro models, neural nets, decision trees, transformation-based learning, naive bias, latent semantic analysis, and this is just some that I listed here. You could basically use any machine learning algorithm that would enable you to do the classification, but the skill is really how do you decide on features. So queues are very popular to use as features, and I've shown an example, some selection of queues that have been used for many years now, and sequence of dialogue acts. So I said there are certain questions that follow up with the answer and so on, and this is very important. Collocational, so this is when certain words always go with certain other words. So this is a strong indicator that basically this is a certain dialogue act type and so on. Syntactic is around a certain grammatical structure. So I mentioned yes or no question. It's always, could you do something is obviously probably yes or no answer. Or is there, something is probably yes or no and so on. And prosodic is basically the audio features. So pauses, pitch, raising voice, and so on. And all of these could be actually used for detecting dialogue act types. So some of the examples here, and if you're interested in the topic, I do recommend reading Nick Webb's thesis, which kind of goes into details on the classification of dialogue act types. So here are some of the cues that you could use. For example, if you say, however, probably you are starting a new sentence. Or if you say, obviously, or if you say, now. So these are things that you could actually use to kind of distinguish different dialect types. And now, in the remainder of this talk, I'll talk a little bit about some of the challenges that are related specifically to spoken language. So everything I said so far could be applied to chatbots, could be applied to voice bots. There are certain things that you actually have to consider when dealing with voice bots that you don't have to deal with otherwise when the language is written. You have to deal with other problems there with like misspelling errors and so on, but I would say it's easier than in the case of spoken dialogues. So first of all, I mentioned there's a word error rate. Utterance segmentation is another one because we don't actually have sentences. We have to split them. We have to make them up in some ways. And diarization, which is basically a problem of which speaker is talking and when. And this is quite difficult, especially if you have more than 2 speakers. So I've shown an example before around Dach, Smith, and so on. So this basically, if you use systems, and today I think we actually have many systems that perform quite well. However, when you apply them to a very specific domain, so for example, we use in Sentient Machines, we're analyzing customer calls, and we have different domains. So for example, utility would be quite different from something like retail or media or finance, because the language is quite different. So, and there are techniques to basically train or customize these speech-to-text models in order to make them actually more accurate for a particular domain that you have in mind. What is also very common is that, like in this particular case, we have, and this actually is an example from analyzing human conversations. We have a system that actually works really well on the agent side, but not so well on the customer side. And now this has to do with many things, like agents are usually trained to speak louder, more clearly, and so on, whereas customers are mumbling often and not pronouncing things and so on. And this is actually quite common. You see this basically all the time. So it really depends on where your data is coming from. In terms of utterance segmentation, so this is very hard because we don't actually know, we don't even have a definition of like how to actually, what is an utterance? Like what is it? Okay, it's something that has an intent, but in terms of words and how, when you actually put humans together, how do you actually tell them, please separate this dialogue into utterance? It's very hard. And actually we've done this a few times, and it basically is different people do different things. So therefore the inter-annotator agreement is very low and it's very hard to actually use it. However, certain things can be useful. So I mentioned prosodic features. So often people use pauses. So they use pauses when they want to stop and start a new sentence. You can't just use pause on its own because sometimes if I want to emphasize something, I might just say that word and then stop. So, and even though I haven't finished the sentence, so basically you need to combine these features together in order to maximize benefit. Pitch I mentioned, the stress, so different words you could basically stress differently. Volume, someone is speaking loudly or quietly, and so on. Pace, so if someone is really speaking fast, so if I have 2 speakers, then probably the pace, there will be different pace for both of them, so therefore this will help me distinguishing who is speaking when. Another common approach is cues. So I already mentioned like however, and now, obviously, and so on. So these are often very useful. And of course, n-grams. So n-grams are just word sequences. So when we have a lot of data, we actually can infer what n-grams are usually at the beginning of an utterance and what n-grams are at the end. Now the challenge here is to actually have a corpus that is annotated so that you could actually spot this, because again, as I said, it's actually very hard to define what an utterance is. Turn merging or utterance merging is another concept that's very important. So sometimes if I'm talking and another side is back channeling or interrupting, I need to make sure that when I'm analyzing my speech, I don't actually get distracted with the back channel. So therefore, we need to kind of merge all these utterances together in order to interpret them. So, and of course, to understand speech, you actually need full utterances as opposed to kind of interruptions. So when I said sentences are very hard, so you've seen this example where the bot is actually saying certain things, and in fact, on top, I put something that actually is not quite usual when you're building a bot, that you integrate something like this. However, when you have data that comes with something like this, it actually is recommended to use this because it is adding that more natural feeling. So you know that you're not, well, you think that you're not talking to a robot. Because we do this all the time. So I can see that, yes, I can see that the engineer has visited you already. So it's not just like, I can see that the engineer has visited you already. So now speaking of what's an utterance and what's a turn, each single line here would be an utterance, whereas all three utterances of this bot to the right are actually one speaker turn. Because he actually hasn't, in reality, he hasn't made the pause, he just kept talking. It's just that there was kind of a parallel channel on the other user saying things. The final challenge here in understanding spoken dialogues is what's called diarization. So diarization is about how many speakers do I have and when each one of them speaks, exactly, like in terms of time. And this is very important because again, for example, customer service is very important to understand sentiment of the customer. The sentiment of an agent is important, but not as important. So therefore, it's very important to distinguish who is actually speaking when. So again, coming back to the same example, this is actually what happens quite often. So you can see here that I called you nicely already about first. It's really, really annoying, actually belongs to this speaker, but the system actually thought that it was the other one. Or what's your name and address, please? Again, belong to this speaker, as opposed to the other one. Now, if you look at this, so we spoke about dialogue archetypes. This is a typical example where dialogue archetypes could actually help you to basically solve this particular problem, because usually it's not one user that's asking and answering a question. It's kind of one asks a question, the other one gives a response. So, so this is where something like dialogue archetypes could actually be very, very useful to help the problem of diarization. In terms of applications of spoken dialogues, so all the examples I've been mentioning are mainly related, well, not all of them, but most of them are related to automated conversations. So we are building dialogue systems because we want to automate a conversation. So build a chatbot or voice bot. In some other examples, and this is, for example, what we are currently doing in Sentient Machines, and what I've done in the previous startup, is analyzing conversations. So we are analyzing dialogue conversations, so maybe they are recorded, face-to-face meetings, for example, you record them, and then you're trying to analyze them to achieve something. So I'll give two examples here. One is to discover unknown events, and the other one is to discover some anomalies or predefined events. So I'll tell you in a second what that actually means, because it sounds quite abstract. So automating conversations, I think this one is quite easy. So we all know virtual personal assistants. So it all started with Siri. Now we have them pretty much on any phone. And you could use them to, I don't know, get weather information, to inquire about different services, and so on. We have Alexa to basically do whatever you ask him to do, if he can understand you. So I think virtual personal assistants are quite common nowadays. The other ones I spoke about is a simulation of a teacher. So in my examples, we had biology. We were actually building one for programming as well. So this is where you're basically, again, simulating the certain knowledge base, certain curriculum, and you're trying to basically teach someone something. Finally, customer support. Very, very popular at the moment. I think in London there is like, I don't know how many startups that are actually trying to solve exactly this problem, trying to replace basically agents to a certain extent or automate basically some easy cases of customer service. So when you call customer service, you don't have to press 1, press 5, and so on. You actually can use natural language and solve your problem. So in terms of analyzing conversations, the next one I'll just want to mention is discovering unknown events. And this is actually what we currently do in Sentient Machines, which is basically detecting frustration. So you have a phone call, it's being recorded, it's happening. Can we detect in real time that people are frustrated? Because maybe we can do something about that. So it's not just about what we say back to make them happier. Could we actually improve our services so that this person doesn't have to call again? And this is basically how it looks. So you would plug in your calls, and then you would